Hello! In this feature of the week video, we will explore an important concept in pharmacometrics, accumulation ratio, and we will see how to calculate it easily using PKanalix. So why does accumulation ratio matters? Accumulation ratio is an important parameter for analyzing the efficacy and safety of a drug under repeated dosing. Some drugs require a certain concentration level to achieve the desired response, and in this case, the interdose interval is kept short to allow drug accumulation. On the other hand, for drugs where toxicity is concerned, the interdose interval is longer to allow for drug elimination and prevent excessive accumulation. So, what is the accumulation ratio? When a drug is not completely eliminated before the next dose, the accumulation ratio describes how much it is accumulated in the plasma, and it depends on the dosing interval and on the rate of elimination of a drug. So how do we calculate accumulation ratio? The most common way to calculate the accumulation ratio is to use the observed data with measurements after a single dose and at a steady state, or after a sufficient many doses. Then the accumulation ratio is the ratio between the exposures of these two periods. So exposure at steady state with respect to exposure after single dose. Its value is greater or equal to 1, with 1 meaning that there is no accumulation. Exposure metrics in this formula can be Cmax, Ctrough, or AUC tau, which is partial AUC in each interval. But in practice, mostly AUC tau is used because it uses all observation points in a given interval, so measurement errors average out and the results are more robust. So now let's see how to calculate accumulation ratio in PKanalix. In this project, I loaded a dataset with concentration measurements at day 1 and at day 14, which I consider to be a steady state. In the dataset, these 2 days are separated with occasion. It allows to compute NCA parameters for each of the 2 dose intervals. Let's look at the observed data. If I split this plot by day and use the same y-axis limits, I see that the concentration profiles are only slightly higher on day 14. So the accumulation ratio probably is limited, but I will quantify it by calculation precisely the accumulation ratio. I can define a ratio between any 2 periods for any computed parameter using a ratio module which is in the task tab for NCA. The module is here. In this case, I want to calculate the accumulation ratio as the ratio between AUC on day 14 and on day 1. So these 2 days, day 14 and day 1, are 2 interdose intervals, so I need AUC tau parameter. The AUC tau parameter does not appear by default in the list of parameters here. To add it, I must first define the interdose interval duration, and I can do it in the calculation section by selecting the option interdose interval for single dose profiles. When I add it, the AUC tau appears automatically and is automatically selected for computation. Here, the interdose interval has the same units as my time column in the dataset, so in my case it's 24 hours. The next step is the definition of the ratio. So I go to the ratio module and I create a new ratio. I call it AR AUC. I select parameter AUC tau and have day 1 as a reference and day 14 as test. In this way, the value of AUC tau on day 14 is in the numerator, and the preview formula below helps to verify that the definition is correct. I create the ratio and I can run the analysis. Once we run the analysis, the ratio results are displayed in 2 tables. The individual values of the ratio are in the individual ratio table with 1 column per ratio. And the summary table shows statistics of the ratio across individuals. In this example, the mean accumulation ratio is around 1.26, which is relatively low value. And how to calculate accumulation ratio with leaks of connectors? With leaks of connectors, you can create, check and delete ratios, as well as retrieve statistics and individual values. And that's it. Accumulation ratio is an important metric for evaluating drug accumulation in multiple dose regimens. And as you saw, it's easy to calculate in PKanalix. Thank you for watching. Be sure to check our documentation for more videos.